Let me screen record for those who are not going to be able to view this. So if you are watching from home, take a minute to try this problem. So, we'll go ahead and get started. Let's see what we got here. So maybe I can hear from a couple of y'all who most of us said B. So let's start with Carla. Tell me what the H and the K is. We'll just define what the values are here. So what is H and what is K on of this?
H is 0 and K is 0.
And why is that?
It's in the origin. The
Okay.
center point is in the origin.
Okay, so the center is in the origin and H and K is the center. Okay, good. Jimena, help me out. What's the A and the B?
The A is 4
Okay, why is that?
because that is half of the major axis.
Okay, good. And the B?
2.
Okay, good. And so those of you said B, you're saying because it says A is greater than B. That is true. A is greater than B, so it can't be that. And then 5 says H is equal to 0, K is equal to 0. That is also true here. And that would therefore make these false. Yes, so B would be the correct answer. Very good. So that's just a refresher on the A and the B. Okay. So we're going to get started. Today's lesson is ellipsis part 2. We're only having 2 days of lessons on ellipses. We're in our unit of conic sections, which, as a reminder, something that comes up in BC calculus. We're going to do ellipsis part 2 today, which we talk about eccentricity and things like that. And then next week, we'll do hyperbolus. Tomorrow, no class, just Zoom office hours. If you have any questions, be online at 10. If you don't, no worries. You can get some rest, catch up on work, whatever you need to do. And all practices are due tomorrow. Okay. If at any point you need an extension, if you feel overwhelmed or anything like that, you just send me a message on Remind. We'll talk about it and figure out a way to make it accommodating. But all practices are due tomorrow. Okay. Okay. So we'll go ahead and get started. As always, say our 4 goals. We will learn math, build character, never give up, and ask why. All right. So let's go ahead and jump into it. All right, so last class we talked about ellipses. Specifically, we talked about the kind of the vocabulary words, major axis, minor axis, what is the A, what is the B, center, all of that, right? And we talked about these 2 equations. And just as a reminder, the main difference between them is it is a horizontal ellipse if the A is under the X, that is horizontal. It is a vertical ellipse if the A is under the Y. And this can be written interchangeably, like this whole thing could be first, right? Either way is fine. We're going to talk about today specifically is the foci, more about the foci and the relationship between A, B, and C. We talked about A and B, we didn't talk about C, so that's what we'll talk about today. All right, so let's look here. Just a quick refresher, just to make sure we're good, because we need this prior knowledge. As a reminder, the major axis is the longest, minor axis is the shortest, the axis being what cuts it in half. A is half of the major axis, B is half of the minor axis. And the same applies for when it is vertical. Okay, that's just the vocabulary words we talked about there. Okay, so what is the C? So we talked about the focus and how the way you kind of draw an ellipse is you can put 2 focuses and you can put a rubber band, right? And then you take that rubber band with your pencil, go all the way around, and it creates an ellipse, right? And we talked about how if you pick any point in the ellipse, the distance between one focus to that point and the other focus to that point, and you pick another point, those distances, this distance plus this distance is equal to this distance plus this distance, right? We talked about the distances between the 2 points on an ellipse when you add them together is equal to any other distance on another point that you add together, right? So the C that we're introducing is just the distance from the center to the focus, okay? So instead of from the center all the way to the end, the C is the distance from the center to the focus, okay? So this is C over here. This is also C, okay? So C is the distance from the center to the focus. Distance from the center to the focus. Okay. There is a relationship between A, B, and C. But before we talk about that, just one thing to note there, question to think about. Which one will always be, so what is the order, let me clarify, what is the order from smallest, no, let's not say that. Rewind it back, ignore what I just said. Which one will always be bigger, the A or the C? Think about that. Which one will always be bigger, the A or the C? Or will it always be bigger? So which one will always be bigger, the A or the C? And will it always be bigger? And let me know when you have your answer. You can unmute yourself and share. Which one will always be bigger, A or C? And will it always be bigger?
The C doesn't go all the way to the end, and A does. It's like the half of the ellipses.
Kevin, what do you say?
A will always be bigger.
A will be bigger than C? Same reason?
Yeah.
Okay, very good. So that is correct. So A is always going to be bigger than C because the focuses or the foci will always lie in between the ellipse, right? The focus is never going to be out here. If they were out there, then the C would be bigger, but the A will always be bigger than C. That's important to note there, okay? And then remember, the A is always bigger than B because B is half of the minor axis, okay? So we have this relationship here between A, B, and C, and this is on your formula sheet. C squared equals A squared minus B squared. Looks similar to the Pythagorean theorem, but the Pythagorean theorem has a plus here. So where is that coming from? C squared equals A squared plus B squared, okay? If you were to take a ruler and you were to take that ruler and you were to measure this, okay? And then you take that same distance and you try to find where else on this ellipse do you have that same distance. One would be over here, right? That would be the same. Another one would be the distance from the focus to the co-vertex, okay? So here's a focus right here, and here's a co-vertex. So if you were to measure this distance, it would be equal to this distance here. So if this is, we're calling this distance A, we can say this is distance A. They're always going to be equal, no matter what the ellipse looks like. That's always going to be the case. What that means, therefore, is to see the relationship between A, B, and C, we have a right triangle right here, and we can use the Pythagorean theorem. So we can say, but now it's not our traditional A, B, and C, because usually C we represent as the hypotenuse. So we're just going to use A as a hypotenuse. So it's going to be C squared plus B squared equals A squared. And if you note there, this relationship between A, B, and C is solved for C squared. So to solve for C squared, you would subtract the B squared. And you get C squared equals A squared minus B squared. That is the equation for the relationship between the A, the B, and the C. I always like to show you why the formula is there, not just start using the formula so you can try to understand conceptually what is going on there. So C squared equals A squared minus B squared. That's where that's coming from. So you have to remember that it's given to you in the formula sheet. You have to remember the relationship between A, B, and C because it will help in a problem. Okay, so let's try one. So let's say, oh, one more thing to talk about, sorry. Right here. You don't really have to remember this formula because you don't really, or not formula, but this relationship, because you can kind of know it intuitively, but just so you see why this says this right here. The foci, this is the x value of the foci, This is the y value of the foci, right? And so this is just saying, like, if you have H, which is the center, and you add or subtract C. So here's C right here. So let's say your C was 3. And let's say your center was 2,5, for example. Okay. So if it was a horizontal ellipse like this, then this distance was 3 right here. Then this focus over here would be 5,5, right? Because the distance is 3. We're looking at this as like on the graph of the x and y axis. Like this is the x axis and this is the y axis, and you had your grid lines. If this was 2,5, this point over here would be 5,5. And then this point over here, if you went left and the C is 3, you'll be going -3. So 2 minus that 3, this point over here would be -1,5, right? Figure not drawn to scale, but generally, yeah. So this is just showing you that if it is a horizontal, because this is the horizontal, this whole column here, that's just showing you that if you were finding the foci, it will be the H. You would just be adding to the H because it's going right or left. And so you would add whatever the C is. So in this case, the C is 3 to get this point, which is the foci. And then over here, you would go left. And then for a vertical, it would be like if it was vertical, your foci would be up here and your center would be up here. So you would be adding and subtracting to the y value. So that's all this is showing you. I don't usually refer to this because I usually just draw the graph to get a visual of it. But just so you know what that's talking about there. Okay. Any questions on this section so far of the equations of the A, B, and C, and any of that? And any questions? If you're good, you can put a thumbs up or you can write in the chats. Okay, so I don't have any questions so far, so we'll go ahead and move on. So let's say we want to find the foci of this particular ellipse right here, okay? So I always like to do a visual and draw a graph because it helps to visualize. So we need the center, or we have the center. Hugo, help us out. What's the center here? Hugo. Hugo? Maybe he had to step out. So Tammy, what's the center here?
-1,1.
Okay. So I'm going to draw that to get a visual. And then Brianna, what's our A here?
A is 5.
Okay, good. Remember, A is a bigger number, and this is A squared. So 5 squared gives us 25. Jocelyn, what's our B here? Okay, good. 3. She wrote it in the chat. So then we can draw an ellipse based off of that. So our A is 5. So therefore, and wait, we need to determine, is this vertical or is this horizontal? So let's do, Anna, is this horizontal or is this a vertical ellipse? Anna, is this a vertical or horizontal ellipse? Okay, she said in the chat horizontal because the A is under the X, right? Okay, so we're gonna go to the right 5 then. That's where our vertex will be, and to the left 5. That's where our other vertex will be. Okay. And then our B, which is 3, we're going to go up 3 and down 3. Okay. So that is our ellipse there. Okay. So what we are trying to find is the foci. Now, the first thing to note is whether the foci are going to, we know the foci are inside of the ellipse, but we need to remember, are the foci going to be right here in between the vertexes, or are the foci going to be right here in between the co-vertexes? So thinking back to what we talked about at the beginning, where would the foci be? Would they be in between the vertexes here, or would they be in between the co-vertexes here? Anybody can unmute themselves and share. Where would the foci be? Here or here? It could be over here. It could be in here, right? We don't know where exactly it's going to be, unless if we had a ruler and we were able to like try to pick a point and then measure, okay, are these two distances equal to these two distances? But that would be a little bit difficult. So we know they're somewhere along this line. So what can we use that would help us to find where they are? Thinking about all the information we have thus far. We have the center, we have the A and the B. So what could we use to help us to find the foci?
Can we use the equation?
Say that one more time.
Can we use c squared equals a squared minus b squared?
Exactly, yeah. We can use this formula because we know C is the distance from the center to the foci. And so we can use that to find C first. So C squared equals A squared, so 5 squared, minus B squared, which is 3 squared. So C squared equals 25 minus 9. So C squared equals 16. And then when we square root 16, it's important to note that when you square root 16 while in the process of solving, you do end up with plus or minus 4, but we're not using the minus 4 because we're talking about distance. So we're just using 4. So the C is 4. So that helps us because that means that the distance from the center to the focus is 4. So if we count from here, 1, 2, 3, 4, that means that our focus will be right there. And to the left, 1, 2, 3, 4, our other focus will be right there. And the importance of the focus, if you remember, for the circle, the center is important because everything is equal distance from the center. But for an ellipse, everything is, all the points are equal distance from the addition of the distances between the two foci. So our foci will end up being 3, 1 is this one, and -5, 1. Okay, so that's how you use that last equation of the relationship between A, B, and C, and that's how you find the foci with that. Okay, so that's kind of the other piece of ellipses. We're going to talk about eccentricity here in a minute, but why don't y'all try this problem? I'll give you some time. So try this problem. It says write an equation for an ellipse with a major axis of 6 and a foci of 3, 0, -1, 0. I'll give you some time to try that. Let's talk about it. So first thing we should have done is written the foci, like drawn it to get a visual. So we got 3, 0 and -1, 0. Wait. 1, 2, yeah. Give me 1 second. Someone's knocking on the door. Hold on. Sorry about that, yo. Where was I? Okay, so we have the foci at 3, 0, negative 1, 0. Based off of just that, we can find two things. We know the center is 1, 0 because the foci are equal distance from the center. So therefore the center is going to be in the middle. Just like it's equal distance from the co-vertexes, it's equal distance from the vertexes, the center is in the middle. We also can find the C, because C is the distance from the center to the foci. So that would be 2 in this case. All right, so you can find both the center and the C just from knowing the foci. Okay, then we know it has a major axis of 6. And remember, major axis is the longest, and major axis, if you think back to this graph here, the major axis, the two foci will always lie on the major axis. Foci always lie on the major axis. So because of that, our major axis has to be horizontal because our foci are horizontal. So it can't be vertical. That's important to note. You kind of have to remember the relationship between all of these things and put it together. So because a major axis is 6, we'd have 3 to the right and 3 to the left. 1, 2, 3. 1, 2, 3. So that is these are our vertexes over here, the ends. So there's a lot of vocabulary here. Based on knowing the major axis and where your vertexes you know that this is 3 and that is your A. A is half of your major axis. So once you have that information, you have really all that you need, because you can now use the formula. You don't even really have to graph anymore. You know generally it's going to be shaped like that, something like that. So you can use the formula c squared equals a squared minus b squared. So 2 squared equals 3 squared minus b squared, and you solve for b. So it's going to be 4 equals 9 minus b squared. Well, let me pause. Do I have any questions thus far? I don't know if I'm going too fast or anything. Just want to make sure we're good. Okay. So then we subtract 9. We get negative 5 equals negative b squared. It's just solving algebra. Divide by negative 1. So we get b squared equals 5. Then we square root. We're going to have b equals. We're going to leave that as a radical. We're going to leave it as square root of 5. I'm not going to put it as a decimal because it will help to leave it as a radical for later. So we know our b is radical 5. And all we need for an equation is we need the a, we need the b, we need the center, and we need to know whether it is horizontal or vertical. Zane wants to say hi. I don't know if y'all can see him back there. He's just eating the window. All right. Hold on, buddy. I'm teaching. Okay, hold on. Let me just give me a second. To write the equation. Oh, but we need to know whether it was horizontal or vertical, right? So is it horizontal or is it vertical?
Horizontal.
Okay, good. Because our vertexes are horizontal. So we're using the horizontal equation, which is where the a is under the x. So this equation here. So it's x minus, our h is 1. Over a squared, which is 3 squared, which is 9. Plus, now right here, we have a k of 0. So if the k is 0, then you're not going to put y minus 0. You could just put y squared. and then b at the bottom squared. Here's where it helps to leave it as a radical. Because you plug in square root of 5 here, the square root of 5 squared is just 5 because the square and the square root cancel out. And that equals 1. So that is the equation of our ellipse. And we could double check that if we want to do by graphing. If you remember, I showed you how to do that. You go to the graph, you go into relation. Let me actually show you a couple cool features. Well, I don't know if you can do it on this Inspire, but let me try it. So if I hit delete and go to relation, what was the equation? Can someone read me the equation?
X minus 1 squared over 9 minus y squared, over 5.
Thank you. Whoa, I put minus. Did I put minus in the other thing when I wrote it? Oh, yes, okay, plus. We'll talk about that later. That's going to be a hyperbola. There we go. Okay, so you can kind of double check and see. You can see the I can't write on the calculator, but you can see the vertices. There is a way, which I'm not sure. Like, you know how in the regular calculator you have like that menu? No. Let's not do that. You know what? Hold on. To this one so that you can see. So there's probably is a way to do it on the iPad. I was working on the iPad Inspire. Probably is a way to do it, but I'm not sure. I need to mess with it. But if you have the regular Inspire, just so you can see, there's a feature here when you go to menu and then analyze graph. Can y'all see my, are y'all looking at my calculator right now?
Yes.
Yes.
So if you go to menu and then analyze graph and then analyze conic, some of the different features come up. So like, let's say you wanted to check the foci, you can click this, and then when you highlight over it, it'll show you the foci, which is what our original question said, -1, 0, and 3, 0. And you can kind of mess with it and do different things. Like if you want to see the vertices, and then you can kind of highlight over this, and it'll show you the vertices out here, 4, 0, -1, 0. So just a feature that you could use. It might be on the iPad, I'm not sure. So center, vertices, foci, axis of symmetry, that's for parabola, Asymptotes, we'll talk about that later. Radius is for circle. Eccentricity, we're about to talk about that right now, actually. Okay. All right, so let me get back to the iPad. Any questions on that problem? That problem there that we just talked about before we talk about eccentricity, which is the last piece of ellipses. Okay. On the very bottom of the section for conic section, there's a piece that says eccentricity, and it says E equals C over A. That's showing you the relationship between C and A and how that relates to something called eccentricity, which we're about to talk about right now. Okay. So the formula for eccentricity is C over A. What C over A tells you basically is how you could think about how round or how circular or how stretched the ellipse is. Okay. So the more circular it is, I would say, the closer it is going to the eccentricity, E being eccentricity, is going to be to 0. The more stretched out it is, the closer the eccentricity is going to be to 1. Okay. So the more circular it is, the closer the eccentricity will be to 0. The more stretched out it is, the closer the eccentricity will be to 1. But eccentricity will always be between 0 and 1 for an ellipse. Eccentricity will always be between 0 and 1 for an ellipse. It's not going to be 0. It's not going to be 1. It's going to be between 0 and 1, not including 0 and 1. Okay? Talk about why in a second. Thinking about this mathematically, C is the distance from the center to the focus, and A is the distance from the center to the vertex. And we said A is always bigger, so this one is bigger. If you remember, we talked about it earlier, and this one is smaller. Depending on how much bigger and how much smaller they are from each other will determine how stretched the ellipse is. Because let's say, for example, the foci, were really close to the edge. That is going to make the ellipse more stretched out. So let's just say that the A's distance was 10 and the C's distance was 9. If eccentricity is C over A, then it would be 9 over 10, which would be 0.9, right? Which would be closer to 1 because the C is bigger and it's closer to the A. So that makes the fraction closer to 1. If the C, let's say that it was slightly more towards the center, and let's say the A remained at 10, but now the C's distance is 7. Eccentricity again is C over A, so it'd be 7 over 10, that would be 0.7. So you can see as the focus gets closer to the center, the eccentricity decreases and it becomes more circular. Let's say again the A remains at 10 and the C is now closer to the center. I mean, it's going to make the C smaller. Let's say now the C is 3. If eccentricity is C over A, it'd be 3 over 10, which would be 0.3. So the eccentricity is getting smaller and it's getting more circular as the focuses move more towards the center. If the foci and the center are in the middle, they overlap, then if you think about that means that if your eccentricity is C over A and C is the distance from the center to the focus, but the focus overlaps with the center, then your C is just essentially 0. There's no distance between the center to the foci. So 0 would be, because there's no distance, 0 would be the C, and the A would be still remaining, let's say it was 10. So that's just 0. That is, however, a perfect circle, because now what we're looking at is the distance from the center to the edge anywhere is equivalent. That's by definition what makes something a circle. So it's never going to be exactly 0 because that would be a circle. It's never also going to be exactly 1. Think about why. Kind of stretch our thinking for a little bit. Okay, hold on. So I accidentally paused the recording. So for those who were or watching it later, the answer was Anna said that it was not possible, and Brianna said because it would be a line. Let me share my screen so that you can see what I'm a visual of the eccentricity if you're still a bit confused about that. Give me a second. No, that's the wrong screen. Okay, so here's just another visual. Can y'all see the ellipse on here?
Yes.
Okay, cool. So eccentricity being C over A. So let's say our A remains as 4.7, that I don't change this 4.7. Because remember, the A could be the distance from the center to the vertex, or it's also that diagonal. They're equivalent. So let's say that we begin, as I'm doing this, what is happening to the C? As I'm going down, what's happening to the C, the value of C? It is increasing or decreasing? As I'm going, increasing. Right? So as I'm going this way, the C is increasing. Look at the eccentricity. What is happening to the eccentricity as the top value increases, but the bottom value remains the same? What's happening to the eccentricity?
It's increasing.
It's increasing because the top value is getting closer to the bottom value. Now, if we continue going like that, it's getting closer. The eccentricity is getting closer and closer to 1. But when it gets to 1, it's now a line, right? Because the A and the C are equivalent. And then going backwards, as the eccentricity decreases, the C decreases, and it becomes a circle when the eccentricity is 0. So that's just kind of like a visual of that if you had trouble seeing it the other way. Okay. All right, let me go back to sharing this. Okay. Can y'all see my iPad screen now? Oh, Hugo, I just saw your message on the chat. Hugo said it was a line. You're right. Can y'all see my iPad screen?
Yeah.
Yes.
Okay. And y'all can hear me? All right, cool. Okay, so let's apply eccentricity. This will be the last problem we do together. And then I want you to maybe try one if we have time. So we'll do the one on the left, and the one on the right is a little bit easier. We'll do that after. Ellipse centered at the origin has a vertical major axis of 8 units and an eccentricity of 0.5. What is the equation of the ellipse? So let's pull all the important information we have from this. It's centered at the origin. So the center is 0, 0. We have our H and our K already. It says it has a vertical major axis. Because it says it has a vertical major axis, that tells us that the ellipse is vertical, right? Because if it has a vertical major axis, the longer side is vertical, so it's a vertical ellipse. If it said it had a vertical minor axis, then that would be saying the vertical is a minor axis. That would be horizontal. So you gotta really know the vocabulary there. So this one is vertical. And it says that the major axis is 8 units, which therefore will tell us that the A is 4, because A is half of the major axis. So we have our center, we know it's vertical, we know the A. Really the only other thing we need is the B in order to write the equation, because we have H and K, we have A, the only other thing we need is B there. So the information we have is that the eccentricity is 0.5. And eccentricity is C over A. Because the eccentricity is 0.5, that's a medium stretched ellipse, you could say, because 0 is really, 0 is a circle and 1 is really stretched out. 0.5 is kind of in the middle. It's kind of a medium stretched ellipse. So if it says eccentricity is 0.5, we can say that E is 0.5 equals, we don't know C, we can say C over, we know A is 4. You'll see that. So we can use the formula for eccentricity of C over A to solve for the C. And once we solve for the C, we can solve for the B. And once we solve for the B, we have everything we need. So if we solve this, multiply by 4, we're going to get C equals 2. Half times 4 is 2. Or you can just think 2 divided by 4 is half. Once we have C, we can find A using the formula C squared equals A squared minus B squared. It's all connecting. So then we got 2 squared equals 4 squared minus B squared. We just solved that, do some algebra. That's going to be 4 equals 16 minus B squared. Subtract 16. Negative B squared equals negative 8. No. Why did I get 8 from? 12. Y'all know I mess up on basic algebra sometimes, or basic numbers, elementary school. I don't know why. You always correct me. Then we divide by negative 1. We get B squared equals 12. Square root. B equals the square root of 12. We're going to leave that as a radical. We're not going to simplify the radical for now because it's going to help us later. Okay, so we have everything we need. We're using the vertical equation because ellipse is vertical, and that's this one with the A under the X. So it's going to be X minus, our H is 0, so we're not going to put X minus 0. We're just going to put X squared over a squared, which is 4 squared, that's 16, plus y minus k. Our k is 0, so we're just going to put y squared over b squared. B is square root of 12. So remember, when you square root of 12, square and the square root cancel out, you just get 12. That equals 1. And we have the equation of our ellipse, which we could check if we wanted to by graphing. Any questions?
Isn't A supposed to be over Y? The major axis over Y?
Say that one more time.
The major axis is supposed to be over Y, like under Y in the equation because it's vertical.
You are 100% right. Yes, thank you for correcting me. I just said a minute ago, y'all correct me. Thank you. Yes, it is vertical. I'm using the horizontal equation. Correct. Thank you. It has to be under Y, so we can just flip these. So this is 16, this is 12, right? Thank you, Carla. Yes, so just to clarify, if I confuse you, my bad. And because it's vertical, when it's vertical, the A goes under the Y, and the A here is 16. Or sorry, the A is 4, but 4 squared is 16. So the bigger number goes under the Y because it's vertical. Yes, thank you. Yeah. All right, just make sure you understand eccentricity. This is not writing the equation. This is just finding B. So let's say it says if you have an ellipse has an eccentricity of 3 over 8, what's the value of B? So as a reminder, eccentricity is C over A. So like if you have that, you could just say C is 3, A is 8. And then to find B, you would just be using this formula, right? So you would just have 3 squared equals 8 squared minus B squared. And then you would just solve for B. That's what it's asking for. We won't have to solve that because that's what we've been doing, but just to make sure you know how to set those up because that comes up in the practice on this topic. All right, any questions on ellipsis, part 1, part 2, eccentricity, vocabulary, foci, C values, life? Any questions? Okay. One quick thing, correction on the practice. So if you have the practice printed, you can turn there. If you don't have the practice printed, just write this down because I noticed when I made the key, I found a mistake. On the front page of the practice, the fourth question, 1, 2, 3, the fourth question on the practice for this lesson, ellipsis part 2, it says write the equation of an ellipse that has a center at the origin with a major axis of 30 and eccentricity of 0.8. So it's the fourth question on the practice. It didn't specify whether it was vertical or horizontal, and you didn't have enough information for that. So on the fourth question, just write that it is a vertical ellipse. So again, on the fourth question on the practice for ellipsis part 2, just make sure to take a note there that that is a vertical ellipse. Okay, so that's your practice for today. Okay, tomorrow is Zoom office hours. There is no class per se, but if you have any questions on the practice, you can log on. I'll be on here at 10. If not, totally fine. And I'll put one more question up here. I want to be respectful of your time. It is 11:12. It's been an hour, 12 minutes. So if you need to go, you're welcome to go. I'm just going to leave this up for those who want to confirm that they feel confident with the lesson. You can try this problem, and I'll go over it after. But if you need to log out, you can. So we'll close there. If you want to stay on and try this problem, you can, and I'll go over it after. Okay. If you need to go, have a great day. All right, I left the work up there. The answer should end up with C. If you're still working, totally fine, but you can take a minute to look at that. You can put a thumbs up if you're good.